See what has happened. Then I want to make sure it starts with. So you are live on YouTube. Good. So go back to Zoom now. Right, and just close this thing off so you get some more space to see what we know. So when you're ready to end the stream, when you want to
stop live stream. Okay.
So you stop the recording like you normally would, and so you stop.
Oh,
Don't click on it.
stop.
Yeah, don't click on it now.
I know.
Don't.
Okay. You're live, right?
Yeah. You're live right now.
Yes, you are.
And I'm muted.
Yes, you are.
Yes, you are.
Okay. Right. Okay. So, Prof, excuse. We're ready. We're ready.
We're
So
ready?
you can. Yeah.
Okay, all right.
Natasha, you're hearing us, right?
Natasha, can you hear?
Okay.
You're welcome. Okay. And yes, I'm Festus, available from Process Engineering. Okay, and I'm really standing for Dr. Manuel Knight, who is the actual head of the Postgraduate. This afternoon's candidate is Balgobin, and he'll be working on, I just shortened it, anthropogenic pollution on the west coast of Trinidad and Tobago. He's looking at the consequences of this. He carried out this research under the supervision of Dr. Natasha Hussein, who until recently was the head of our biomedical unit here in UTT. He's now in Canada. And so you're welcome, Dr. Natasha. Can you hear me?
Thank you, Professor. Yes, I'm hearing you.
Okay, all right. Well done. Now, the external examiner today is Dr. Naru Banju here. He's got many years' experience in the Marine Affairs Institute here with us. Okay. He's a specializes in pollution monitoring, land and environmental monitoring in land and sea. So we're really fortunate to have you here with us as an examiner. And the second examiner, internal one, was on the team itself, advisory team, is Dr. Denise Beckles. You're most welcome. He's from UE, our sister institution here. Happy that you helped us with this thesis. The fourth examiner is Dr. Mr. Denis Ramsawak. He's not able to be here with us, okay, but he has examined the thesis and he's written a report, so we'll take that into account. So the procedure is really very simple. The candidate will give a seminar which introduces us to the topic, okay, after which the examiners will question him. And I want to say this right at the beginning, that you can ask as many questions as you want, take as long as you want. You can either have it in one batch or intersperse it with other examiners. So we look forward to this. And after you finish, our audience, I think there are only 2 or 3 members of the audience here. They may also ask questions. Then we will send the candidate out and we'll deliberate on the outcome of all this. And you will decide what to award, what to recommend for award. And then we will invite them and tell them. So that's very good. Right. Thanks. So your candidate.
Just one more thing. Dinesh, he's not able to come. He's abroad and he would not be able to come.
He's told them, but he's got a report.
Okay.
Right. Good day, everyone. Here I'm Balgobin. And to do my oral defense entitled Source Apportionment, Ecological and Human Health Risks of Anthropogenic Pollution on the West Coast of Trinidad. Today's presentation will just look at the background for this research and the objectives. Then we'll look at the methodology, results and discussion of the data. Trace elements, sediments, stable isotopes, polycyclic aromatic hydrocarbons. Then we look at biomarkers in the marine sediments and pollutant levels in muscle tissues. Then conclusions and recommendations from this research will be presented. There are various anthropogenic activities that impact the marine environment. These include industrial effluent, farming, urban discharge, shipping activities, and offshore activities such as drilling. These activities can negatively impact the environment and the marine species that inhabit these areas. Therefore, it's important that we determine the sources and levels of pollutant in this area for policymakers to effectively make sound management strategies and mitigation strategies in order to conserve this environment. So in this study, we attempt to determine metal concentration in marine sediments, evaluate the human health risks and ecological health risks from using various pollution indices. Then we'll determine the organic origin of hydrocarbons using stable isotopes by utilizing cross plots and mixing models. Source identification and human health risks of the polyaromatic cyclic aromatic hydrocarbons in marine sediments is then determined. The origin of the hydrocarbons in the marine sediments was also then determined using unique biomarkers that are found within the sediments. And we determined baseline levels of pHs and trace elements, mussel tissue collected along the west coast of Trinidad. The methodology we use, we collected sediments from Water Spain area going on through the Carney wetland, all the way to the Lavery Pitch Lake. Collected sediment both in the dry and wet season. Use the IMA boat, the RV Pelagica, in sediment sample collection. PT Puna grab sample are being used to collect the sediments. Collection of the mussel tissues was done from the mouth of the Blue River, going on all the way to the mouth of the Guadino River. This is showing the actual collection of the mussels being done at one of the sites and the mussels that were collected. Equipment used in the analysis shown here: the freeze dryer, accelerated solvent extractor, rocket evaporator, ICP-MS. This is the microwave digestion oven, GC-MS-MS, and the isotope ratio mass spectrometer. Outline of the steps, a brief outline of the steps used for the metal analysis are shown here. We initially freeze dry the sample, homogenize and sieve less than 63 microns, then digested in microwave oven, filtered, diluted, and analyzed on the ICP-MS. For the alkane analysis, similarly freeze dry, then sieve at 250 micrometers. And the sample was then mixed with diatomaceous earth to dry it, then extracted on the accelerated solvent extractor for 25 minutes. Sample then rotary evaporated to about 1 ml, exchanged with hexane. Run through alumina silica column and 2 fractions collected. The first fraction for the alkanes, the second fraction for the pHs. These samples were then dried down to about 1 ml and analyzed on the GC-MS-MS. For the mussels analysis, basically for the same step except added an alkaline extraction step. This is to remove the lipid tissue in the mussels So you can just obtain the pollutants of interest in the alkane fraction or hydrophobic fractions. Similarly, we do the column cleanup and then analyze on the GC-MS-MS. For the stable isotopes, after we freeze dry and sieve the sample, we had to add hydrochloric acid to remove the inorganic carbons because we are just interested in the total organic carbons. Samples, after they were then dried and weighed into the tin capsules and analyzed on the elemental analyzer isotope ratio mass spectrometer. The results from the study are now be presented. Trace elements found generally the elemental concentrations were higher near the urban areas of Trinidad, and mostly around the Port-of-Spain area, had the highest concentration of metal pollutants. But pollution indices, the calculation derived using the pollution indices indicate the most contaminated areas were around the urban area and where all refining activities are located. We also, this analysis revealed that there are unique minerals in these sediments, such as zircon and carbonates, calcium carbonate, which could be indicators of the source material these sediments were derived from. So this is a map showing the spatial distribution of cadmium levels during the dry and wet season. In the Port-of-Spain area at the highest concentration around the Point-of-Pay area. So if we, in the wet season, Port-of-Spain area again, in the Point-of-Pay area had the highest concentration of cadmium. Also, if we look at mercury, seen a similar pattern around the Port-of-Spain area, having the highest concentration of mercury. Now, around the Point-of-Pay area is a spike showing here. So, pollution indices that was used, the numerical pollution index. This just reveals the overall level of pollution, sediment degradation due to the metals contained within this sample. Ecological risk index. This index is used to assess the ecological risk due to the combined elements, the total concentration of the elements in the environment, and the mean effect range median portion is a tool used to evaluate the probable biological toxic effects from metals in the environment. So the this here showing the plot of the pollution index based on numero, but in study area during the dry and wet season. Again, the most severely impacted area, Port-of-Spain, Point-of-Pay area. The potential ecological risk index shows there's considerable ecological risk in environment around the Port-of-Spain area and Point-of-Pay area in the dry season, as well as in the wet season. Risk is slightly not that obvious, but it's seen around Port-of-Spain area and the Point-of-Pay area. For the mean effect range quotient, it just indicates the probability of toxic effects on the organisms in the environment. So the highest, most the area generally had a 9 to 1% probability of adverse effects on marine organisms. Apart from the laboratory area, we had a less than 9% probability adverse effects occurring. Source identification was determined using factor analysis, and this revealed urban waste, agriculture, fertilizer, biomass combustion, as well as fossil fuel and geogenic or natural origin of these elements as possible sources of pollutants. However, we have to be mindful that the Gulf of Paria is shared between Venezuela and Trinidad and Tobago. There are large rivers from Venezuela that drains into the Gulf of Paria. As noted, distributaries from the Orinoco River flows into the Gulf of Paria, where there are many anthropogenic activities such as mining and petroleum exploration are located. So while we determine the source, the country of origin, another is now we move on to the stable isotopes analysis. Following the analysis for stable carbon-13 and the total carbon and nitrogen content, we did cross plots. Use of these cross plots are widespread in this type of research. This help determine marine inputs, terrestrial inputs, and also sewage input. Another type of cross plot is the carbon-13 ratio versus the nitrogen 15 isotopes. This also reveals similar sources, the surge, marine, and terrestrial organic matter. So the plots that was done are shown here for the dry and wet season. You can see most of the points cluster around where there's sewage, as well as marine algae. There's some points falling into the terrestrial plants, as well as fresh water. Similarly, for the wet season, strong cluster around the sewage and marine areas and some terrestrial sources. This plot was the carbon-13 versus the total organic carbon and nitrogen ratio. Second plot using just the carbon-13 and nitrogen 15 isotopes, daily mixtures of sewage, marine phytoplankton, and terrestrial plants during the dry and wet season. Another method that we can use for source identification is a linear mixer model. This has been used to determine not just the source, but also give it the percentage of each source in the environment. So in addition of just identifying the source of the hydrocarbons in the environment, giving it the percentage in the environment. So this just reveal again the following sources was sewage, marine phytoplankton, terrestrial plants. So we map the data using the linear mixer models on these maps. Here the top maps is the dry season. And the most prominent source here you can see is for the marine organic matter around the Port of Spain area, San Fernando, and Labrador. Notice a significant amount of terrestrial material around the Caroni wetland area. And the highest concentration of sewage were found around the Point Lisas area. in the wet season, is lower maps here, showing the higher concentration, greater amount of storage in the organic carbon in the water Cornices area as well as the Guarino wetland. So when you speak of the sewage, it don't necessarily mean raw human sewage. It could be fertilizers, normal household waste, untreated, agricultural activities. So terrestrial inputs here in the wet season very high around the wetland, Carney wetland area. And the marine organic matter input in the wet season is less compared to the dry season. This could be due to increased turbidity in the wet season from flooding that inhibits the photosynthesis during the wet season and contributing to lower marine organic matter observed. Next, polycyclic aromatic hydrocarbons. Generally, found there were higher concentration of pHs in the wet season compared to the dry season. Similar trend was noticed in a study in 2018. The road does show a higher concentration in the wet season compared to the dry season for Trinidad. pH levels were generally higher near urban areas and where petroleum activities are undertaken, similar compared to the metal analysis, seen a similar pattern. Perylene percentage were highest near the Carney wetland area. This here is a map showing the distribution of pHs in the marine in the study area during the dry and wet seasons. The highest concentration of pHs found in Port of Spain and Pointe-a-Pitre areas. For perylene, found high concentration, the highest concentration occurring around the Carney wetland. So high concentration of perylene is indicative of biogenic inputs. Around the Carney wetland area, most of the pHs could be attributed to biogenic inputs. Source apportionment. This was done using diagnostic ratios and positive matrix factorizations, the PMS software. Main sources found were gasoline combustion, diesel, biomass combustion, oil spills, and industrial combustion. So this is the output from the software after I run the analysis for the source apportionment. And this is how we decipher the different sources. Each source have a unique fingerprint. And like for example, the industrial combustion would have the most dominant pHs for the naphthalene and acephnaphthene. This, in other studies, is indicative of natural gas combustion. So that's, with that, similarly for the biomass, diesel combustion, petroleum, and gasoline combustion, looking at these fingerprints from other studies. So the percentage of the sources identified are shown here. For the dry season, the highest concentration, the source was from diesel and biomass combustion. When compared to the wet season, this was less, from 34 to 36%. This could be due to the prevalence of bushfires during the dry season compared to the wet season. gasoline combustion was 27%, and it was higher in the wet season due to increased surface runoff of road dust and other contaminants in this area. So, as with these models, there's always limitations. One of them is weathering. Weathering could affect key pHs that are used to fingerprint the sources, for example, like naphthalene and acetylene. These are low molecular pHs. So over time, these will degrade faster compared to the high molecular pHs, which could affect source identification. You might inaccurately assign the wrong source based on your analysis. So you need to do more studies to identify these sources over time, how they change. Particle size also can affect the distribution of pHs. Sediments with high clay content would have a higher surface area due to the smaller size of the clay. Therefore, will have a higher pH concentration compared to sediments that are very sandy and have a low surface area, resulting in a lower level of pH being observed. Gasoline and diesel fuel in Trinidad and Tobago may not have the same profile as that we use in this research from other countries. We need to active fingerprint Trinidad and Tobago gasoline and diesel to determine whether our profile matches that observed internationally. So health risk assessment now. This was the level of risk was determined using the US EPA scale from negligible, 1 in a million, less than 1 in a million, to potential between 1 in a million to 1 in 10,000. At 1 in 10,000 and more is considered high, and remedial action is suggested in the affected area. So health risk assessment was done using Monte Carlo simulation, using the crystal ball software. In all the analysis, the cancer risk, the incremental lifetime cancer risk was higher than 1 in 10,000. The annual health quotient, or the non-cancer risk, indicate a 14% probability to the population. This is the output from the software for the cancer risk during the dry season, wet season, and annually. And the mean for all of them was above 1 in 10,000. So this indicates that the area is required remediation or mitigation strategies to be implemented in the study area. So the limitations of the health risk assessment, first of all, the bio-sediment accumulation factor. This may not be that was used in the study may not be representative of the fish species found in Gulf of Paria. Consumption of fish by the population may not be entirely from the study, consumed from different areas, west coast or north, east coast or north coast. So therefore, we suggest a comprehensive study of the pollutants in all the seafood species consumed, including the benthic species, crab, shrimp, conchs. And also we should determine all the carcinogens present in the fish tissue, not just for the study, just the pHs, but there are other carcinogens such as pesticides, dioxins, and metals such as arsenic. So, there's other local study that was done in the Carney swamp in 2014 and indicate there's a potential cancer risk. Most of you, results indicate there was a between 1 in a million to 1 in 10,000 chance of getting cancer consuming oysters in the Caribbean swamp. Catfish was also analyzed and the pH levels were generally low, between 7.5 to 43.5 nanograms. Compared to the levels that was used in our study, this was very low. This could be attributed to this area being a protected wetland area, a Ramsar site. I could, the fish species being collected is within the swamp wetland area and not in the Gulf of Paria. So therefore, if we have to use local data, other local data to get more, they say more realistic cancer risk. The other study we can look at is one done in 2012 for catfish. This was collected in the Point Lisas area, just in the Gulf of Paria, just near the Carney wetland area. If we use the values obtained in this study, 0.6 bioaccumulation factor and a 4.7 microgram arsenic in catfish. Cancer risk calculated based on this, these values here. I 1 in 10,000. I'm just using a parameter used for the fish consumption, 5.5 grams per day. There's the alternative model where they do not use the actual concentration of pollutant in the fish tissue, but use the bioaccumulation factor. It reveals similar results, both seasonally and annually. So this is in terms of if you want to actually calculate the cancer risk using local values. This was done in Trinidad. And arsenic is just one element. There's two other elements, the EPA considered carcinogenic, the chromium and the nickel. Next, go on to the biomarkers. So we did the calculations for the carbon preference in that. This is the ratio of the odd number of alkanes versus even number of alkanes. They give you the whether there's anthropogenic activities or biogenic inputs of alkanes in the study area. So it's generally odd number alkanes are originate from biogenic sources, while the even number alkanes are attributed to petrogenic sources. Between 86 to 84% of the sediment samples had pH concentration less than 4 and ratio less than 4. This is indicative of petroleum contamination. Also, all unresolved complex mixtures. These were analyzed, and these are observed, which is generally a hump in the chromatograms. These indicative of anthropogenic sources, anthropogenic inputs. So this here is some pictures of the chromatograms obtained the Porter Spain and Pointe Bay area. See Pointe Bay area, the hump here is higher. This is here is the unresolved complex mixture. That's due to the petroleum activities in this area compared to the Porter Spain area. The Carney area, barely noticeable any unresolved complex mixture. But what is very pronounced is the odd number alkanes, 25, 27, 29. So very dominant in this area. So a plot of the N alkanes revealed that the Caroni area has the highest amount of N-alkanes. That is due to the presence of the odd number of alkanes of biogenic sources. So that accounts for the high amount here. Generally, biogenic sources contributing to the N-alkanes here. But if you look at the unresolved complex mixture, which is anthropogenic sources, you can see around the point of pay area and near the mouth of the Caroni River is high amount of unresolved complex mixture. Also in the wet season, Port of Spain area, point of pay area, and near the library area, at high unresolved complex mixtures. All indicative of anthropogenic inputs. So these are just ratios that was calculated for another set of biomarkers. These are termed the propanes and sterins. And generally looking for is the ratio close to 0.5. And that indicates mature organic material or petrogenic sources. Once you get extreme values like low 0.6, you're looking at biogenic sources. In this study, we identified two unique biomarkers that was in the sediments throughout this study. The trisnophene, this has a biogenic origin, and gamma serine, which is petrogenic origin. This is unique because this is attributed to the Trinidad oil. We have a high gamma serine content because it's due to the formation of the oil in a marine environment. So here's a chromatogram of the propanes, and here this is the gamma serine here, and trisnophene, which is biogenic, and this is the petrogenic source. And the trisnophene peak is very prominent in the Caroni wetland area, again indicating biogenic source, compared to the gamma serine, barely noticeable here. In the point of pay area and library, however, you see the gamma serine peak, it spikes up here, compared to the trisnophene, which is biogenic peak, less. Again, indicating that we're dealing with petrogenic sources here. So based on these findings, we use the gamma serine and trisnophene concentration to determine the sources of hydrocarbons in this area. High levels of the trisnophene being found near the Caroni wetland, Orange Valley, Claxonby mangrove, while the gamma serine was very prevalent from Point of Pay to library areas. So these were the, after we plotted these data onto a graph, and where gamma serine index greater than 1 indicates petrogenic sources, with the trisnophene index less than 0.5, supporting that. However, where the trisnophene index is greater than 0.5 and gamma serine is less than 1, they're generally found in areas where there's limited activities associated with petroleum activities or refining. So this is the graph showing the gamma serine trisnophene ratio. So from the Point of Pay area, Claxonby going on to library, they're all above 1, dry and wet season. These areas are associated with petroleum drilling and refining activities. So I do another cross plot with the trisnophene and the gamma serine index, which is biogenic sources. Most of the points here were from the wetland areas, while the petrogenic source was from the point of view Talabra areas. This area here represents a mixed source, though mostly from the Port of Spain area, indicating mixed anthropogenic sources plus the inputs from the nearby wetland area, the Caroni runoff, also mixing in that area, contributing to this mixed source observed. Another biomarker is stearins. And what we did was a plot of all the stearins obtained from the carbon 27 to carbon 29. Generally give an idea of the environment these hydrocarbons were in, and this here's a plot showing the stearins. And most of these the points were clustered around the estuarine, oak marine area, dry and wet season. The source of the hydrocarbons being attributed to phytoplankton, bacterial and land plants here. This here just gives the source of the stearins are containing, the marine carbonate and marine shale. So the mussels pollutant analysis now. The analysis indicates a general high concentration of 2 to 3 ring pHs compared to the high molecular pHs from 4 to 6. This could be due to the greater solubility of the pHs of the low molecular pHs in water compared to the high molecular ones. So the mussels absorb more of the low molecular pHs. High molecular pHs generally absorbed by the mussels through ingestion of particles containing the absorbed pHs. So this here is a graph showing the source identification of the pHs and the ring profile. Most of the pHs have a mixed source apart from the Gulf View area, where this shows a petrogenic source for the pHs found in mussel tissue here. This is showing the ring profiles, with the green and blue representing the low molecular pHs, and they are generally high, apart from the Guadino area. So, in terms of like how polluted the mussels can be classified, we use a scale from low to high. So pHs generally this range between 100 to 1,000 moderate, and between 1,000 to 5,000 is high. So based on that, this graph shows that the pHs in the study area can be classified as moderately to highly polluted, the mussels. Trace element analysis now on the mussels just indicate the highest level of the elements of metals observable within from the Guadino area. The sources identified via correlation analysis were from waste effluent, from refining activities, industrial combustion sources, shipping activities, and fossil fuel combustion. In terms of in terms of compliance with regulatory guidelines, the cadmium levels exceeded the EU guidelines at the Blue River and Guadino sites, while the zinc exceeded the Food and Drugs, our local Food and Drugs division's guidelines at the Blue River, Felicity, and Guadino sites. conclusions from the study. It reveals there's multiple sources of pollutants in the Gulf of Paria. The petroleum fuel and natural gas combustion generating the most amount of hydrocarbons in this area. Farming activities also is one of the sources that significantly impact in this area. And the potential health impacts due to pH pollution could be considered high in terms of cancer risk. So the recommendations from the study. Based on our national climate change policy, Trinidad and Tobago, where there's proposed incentives for motorists to use electric vehicles or switch to cleaner burning fuels such as CNG instead of gasoline and diesel. Further studies on the pH profiles for Trinidad and Tobago fuel and effects of weathering on chemical fingerprints. And continuous monitoring of this area so that policymakers can make more informed decisions in terms of managing and protecting the coastal environment. Like to acknowledge these organizations that supported this research, in fund the local fishermen, the IMA, and Swim-Pole Port Authority, Conexus Industrial Estate, Seafood Industry Company Limited, Company Development Limited, Ministry of Housing, Ministry of Agriculture and Fisheries Division. That's it.
Thank you. Examiners, do you want to begin, please?
Okay, well, first, Carol Banchu, I would like to thank the University of Trinidad and Tobago for inviting the Institute of Marine Affairs for being part and parcel of this review and also to share with our experience as well. I would first like to commend Mr. Aaron Balgobin and his supervisor for doing this excellent piece of work. I think it was a very difficult study and also one that involves a high level of specialization in terms of the instrumentation involved. So I think this piece of work is highly commendable. Just like to ask a few questions based on your presentation. Concerning the sources of pollution, for which you use different indicators, do you see a correlation between the different types of analytes that you analyze? Like, for example, you analyze the propane fraction, the aliphatic fraction, and the polycyclic aromatic hydrocarbon fraction, and you use these different fractions to look at the different sources in terms of the west coast of Trinidad and Tobago.
Yeah.
But did you look at these three indicators and see a strong correlation based on the interpretation of each indicator in terms of indicating that in a location it is more of a biogenic, it is more of a paragenic, and more of a petroleum hydrocarbon signature?
Yeah, what stand out was the currently wetland area. When it did for the pearline, high concentration, the isotopes revealed terrestrial input was highest around the area. And the N-alkanes total, the standout, they keep showing up as that biogenic source. In terms of the petrogenic sources, however, that was more revealed using the biomarkers, the hopanes, gamma serine, because that's unique for Trinidad. Oil, that shows clear, it stands out clearly. Methylphenanthine and phenanthine the pHs were also very similar to the hopanes, and that revealed the biogenic source, not the petrogenic source from the Point Bay area going on to Labre. It revealed the combustion source around the water Spain area. That was the markers that actually cleared up. It was less confusing compared to the others.
Okay. And considering, well, the major aspect of your research is this aspect of source discrimination between the various types of pollutant. And in the context of Trinidad and Tobago, the issue is one of data interpretation. Sure, or how accurate are you in making these analysis? And taking into consideration, research is something that someone would do an experiment and suggest a correlation that it may be due to this type of pollution source, whether it be a petrogenic or a pyrogenic source. And my observation is that you would have referenced different authors in terms of they using these indicators. But the question is, in terms of research, what is the assurance that these indicators are actually tested? And let me further explain. In the context of accurately distinguishing between a sewage type source in terms of a model, the issue is basically, if you don't have a source characteristic of what is coming from inland Trinidad and Tobago, and you are dependent upon a reference source which may be distinct, right? How can one then really make a confirmatory analysis that this source is linked to this source if you do not have probably the more precise ratios? And do you see this aspect in terms of further development of your work?
Yeah.
Or do you think you have established that level of accuracy?
But no, further research is definitely required in terms of like looking at Trinidad and Tobago